you.
All right, I want to see the true value in that. What I need to do first? Read it. What is that? What does it say? Read it.
If Pat goes skiing, then Amy stays at home. And Amy does not stay at home, then Pat. What is that word?
Cadet will play video games. Cadet will not play video games. Therefore, Pet does not go what? Skiing. Okay, what we're going to do? We're going to write the symbols first. You know what I told you to do when we started this? We're going to write our symbols first. So based on this, we have how many statements before we get to the conclusion? Three. This is 1, 2, and then we have what? The third, right? Then we have a what? Like that. Okay, so P. Write out what P is. What's P? And what's the next one? Which is who?
Q.
What do I have now?
R.
Yeah, you have R.
Huh?
R is cadet will not play video game.
Okay. Because we don't need Amy does not stay at home because what are we doing? Negating what?
Q.
Q. So we don't need that. Right through that?
Yes.
So what we do need, cadet what?
Will
We'll play what?
play video games.
How you pronounce?
Is that an A?
C-A-D-E.
Katie?
Katie? K. That's K.
I just put a T at the end.
So K will play video games. All right, what's next?
Then you're going to have your if P then Q statement. Then your if Q then R statement.
Okay, so we don't need any more letters, right?
Right.
Everybody see that? Get out that cell phone. So next thing, we just actually got our P, Q, and R. What's our next thing we're supposed to do?
Construct your truth table.
You need to be writing. You got this now? Oh. All right, next thing, I need to set up my symbol. I need to set this up in my symbolic format. So I have the first statement is what?
If P then Q.
If P then Q. Then the next one is who?
If Q then R.
So I'm going to write what?
I mean, not Q then R.
Not Q. And then the arrow. And R, right? Amy does not stay at home. This is negating this one right here. So it's not Q. And it's the if then statement. So it's an arrow. Okay, and then you have your R. Then what else?
Negation of R.
Then we got to negate our who?
R.
R. That was the last statement. And then I can draw my what?
Conclusion
My conclusion, my line. And when I draw my line there,
is not P.
then it's not who?
P.
P. Because it says, therefore, Pet does not go skiing. Correct?
Yes.
Any questions? Now, next thing, because I want to say if it's valid and invalid, so now I'm going to construct my what?
Truth table.
Truth table. Okay, so I need a P. Oh, let me see. So here is the letter represent. This is what's going to represent the letters. So that's A. That's the letters. Here is going to be the symbolic. Now let's actually write the symbolic statement of this whole thing right here. How did I write that? So this is B. So C, how to write the symbolic statement?
It's the bracket. Is that what you call it?
So it's gonna be this whole thing right here in bracket, right?
Yes.
So a bracket,
Then in
what?
parenthesis, then Q,
Close it.
parenthesis, and parenthesis,
Mm-hmm.
not Q, then R, parenthesis, bracket. No, not R, and not R,
Not R.
bracket,
And then close the bracket.
and
Now this right here means implies, so we're gonna write our what? Arrow. This right here is gonna tell me, because that's what it's there for. So that's telling you implies this bottom right here, that's the conclusion, which is not who.
P.
That's what we're looking for the truth table of. All of this goes in brackets, but then this is a quantity, must go in parentheses, connected with an and, this goes in parentheses, connected with an and then you have not R. All that goes in brackets. Any questions? That's what we're finding the truth value of.
So is it always gonna be in?
Yes. All right, now, we need a P. We need a what?
Q,
And we need a who?
R,
All right, what else we need?
a not Q,
Not Q, not P, and not Q. What else we need?
a not R,
Not R.
uh,
What else?
parenthesis, P, arrow Q,
Okay, what else?
Negation is QR.
Make Q implies R. What else?
not P, the,
Yeah, I
yeah,
need everything in here, right?
yeah,
Okay, so it is. And then what goes here?
the whole thing,
This whole statement. This whole statement right here goes in that last thing here. So you put that there. I ran out of room to put it. Everybody got it? Any questions on that? Because we need a P, a Q, and an R, because we got P, Q, and R, and we need to get all three of them, so we put not P, not Q, not R in one row. Then we need, if P, then Q, so we need that. We also need not Q, if not Q, then, R, so we need this one. Then we need, we already got this. So then at that point, remember we got to put all this together because it's connected by and statement. This, and that. So that's this piece right here. And then after we find the truth value of all of this, we got to imply not who?
P,
P, which is that last statement, which goes in that last thing with the star. All right, now. True, 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 going across. True, true, false. True, false, true. True, false, false. False, true, true. False, true, false. False, false. True. And then false, false, false. 1, 2, 3, 4, 5, 6, 7, 8. All right.
how do you know how many, spaces to do? Because I thought you did it based off how many columns you had.
What? Carl, you talking about roll?
Yeah, how you know how many rows to do? Because I thought it was
Because
based.
we're talking about 3 letters, so you got all these combinations, which is going to be 8, because you got to have 8 different ones. All 3 could be true. Then these 2 statements could be true, but this one is false. Then the Q could be false, but then Q, P, and so you're talking about all the different ways that can be.
I got that, but how you know to do 8 and not 10?
Right. You got 3 elements, so it's 2 to 3. And let me say this. If they're all different combinations given at 3, you got 3 conditions, but it's 2 at a time that you're actually choosing, true and false.
Right.
It's 8 of them, because it's that one. if I had two, then at that point it's only true, 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 false, false, true, and false, false.
It's 8 because it's only that many
It's
different
only three of
combinations.
them.
Okay, got it.
The different combinations.
All right, I got it.
Yeah.
Two questions. What's the combination before the one false?
This bottom, all that. All it is this right here. You're writing this whole thing right here. Bracket, parentheses, you move over here. And Q. Connected with this. Negative Q implies R. Connected with an and, not R. And that implies not P. Right there.
How do you know what different combinations to use for the first three? Is that a standard thing or?
Yeah, it is standard. You gotta remember, y'all can tell me 3 different statements. For the 3 statements you made, all 3 can be true. Then the third, what they're saying is all 3 can be true. You're talking about all different ways that you can have those statements. But you remember, you got 3 ways, but you're talking about the choices are true and false. So there are all the different combinations you can have. Those are all the different ways you can have it. Where all 3 is going to be true, all 3 could be false, then one of them could be true, which means at that point, R could be true, but the next 2 are false. Then you can say that Q could be true, but the next 2 are false. And then you can go where? You can have both P could be false, but then all these are going to be true. There's all different ways like that.
So that's the standard formula?
Y'all not understanding all different combinations that you can bring a statement. You can bring a statement where all 3 statements are what?
True.
You can bring a statement where the first 2 are true, but the last one is what?
False.
You can bring a statement where the first one is false, but the last one are what?
True.
Last 2 true. It's all the different ways that you can have that statement. Okay?
Okay, you were explaining to her, but I didn't get how do you know that it's just 8 rows?
Because it's all different combinations of P.
So all the different combinations just make 8.
It makes
like
8,
that for
right.
every table. Is that
It's
what
okay, just like the set. If I said how many sets are in there, it's 2 to the n power, right? Okay? Because we're talking about how many elements that we have in there. We got 3. But at that point, you got to remember, we're talking about all 3 of those. Okay? All the different combinations, but we're talking about all different combinations of what? True and false. Okay? And when it's 3 of them, it's 8 of them. Are you following me?
Yeah.
Okay? If it was 4, that means a whole nother, 2 more combinations. If we had P, Q, R, and H or something, that means you got to add, because all of them could be true, and then you had 2 at a time could be true, and 2 could be false. Now, all different ways that this possibly can happen when you have 4 different ways of your combinations can go. All right? Now, we want to negate your P. So, negating your P, you're going to have false, 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 and then true, 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 right? Then negating your Q. False, false, true, true, false, false, true, true. Negating, and then when you negate, you're doing the opposite of what that value is. So here we're going to negate R. False, true, false, true, false, true, false, and true. Okay? We're doing the opposite of all those. Those are quickly and easy to do. Any questions on that? All right, now, what is it telling me to do? P, if P, then what?
Q.
Q. What do we know about the if-then statement?
They're all true with the exception of TF.
Right, true, false. Do order matter with the if-then statement?
Yes.
Yes. Order matters with the if-then. That's the only one. So we're looking at the P and the Q, these 2 right here. So that means that this one is going to be who?
True.
Hold on, what are we looking at again?
PQ.
Uh-huh.
PQ.
Okay.
That's what we're looking at. So we got true, true. That just said what?
True.
These 2 are what?
True.
This one is what?
False.
False. This one is what?
False.
This one is what?
True.
This one is what?
True.
This one is what?
True.
And this one is?
True.
There we go. Any questions? Now we here. What are we looking at?
Not Q and R.
All right, we're looking at not Q, which is this right here, and R, right?
Right.
But order makes the what?
Difference.
So I can look at this column first, followed by what?
That column. R
Right,
column.
follow me?
Yeah.
Because we have then statement. So we got FT, which is what?
True.
We got FF.
True.
We got TT.
True.
We got TF.
False.
FT.
True.
FF.
True.
TT. T,
True.
and TF.
False.
Any questions? Now we here. What is it telling me to look at?
Uh,
It's P, then Q, and negation of Q.
This, and that, right? All three of those. Do order matter there?
no.
No, because it's an and connect, right? And it's commutative. Okay, so order does not matter, so it don't matter about that. All we gotta know is that for it to be an and, all what? All have to be true to be what? True. Okay, so we're looking at these three. False, true, true is what? False, the next one is who? True. All of them are true. This one is his. False. This one is what? This one is what? True. False. You only got two truths. Okay, this is false. Any questions there? Now you taking this whole thing, because you take this whole thing, and you implying who? Not who? Not P. That's this right here. That goes here. That's what we're looking at. So we're looking at this right here. If this, then not P, right? So we're looking at this, and we're looking at not what?
P.
Which is here. This and this. Order makes a difference?
Yes.
Yes. So I have to look at this column first, followed by what?
That column.
That column. I got false, false.
True.
I have true, false,
False.
false. And then I have false,
True.
false, which is true. I have false, false, which is
True.
what? I have false, true, which is who?
True.
I have true, true, which is who?
True.
I have false, true, which is who?
True.
And false, true, which is who?
True. So
Is
it's
it valid or invalid?
invalid
Why?
because it got a false.
Got a false there, so it's invalid.
So, for the false, that equals true? When you have two falses, that's true?
With the if-then statement, all of them are true, but the true false. True first, false second, and makes the whole thing look false. Everything else is true. All right? Had a question back there first. All right, over here.
So to determine if it's valid or invalid, they all have to be
True. True to be true.
okay.
The whole last statement has to be all T's for it to be valid. Okay? We got an F, so it makes it invalid.
So if it's all S, it's still
It's all true. Gotta get the college. All T to be what? Valid, right? Other than that, it's gonna be what?
Invalid.
Invalid. Any other questions?
I got two questions. For this problem, could we have used the Euler diagram to solve it?
No, that's
Okay. And
no, you're gonna do this with more conditions. When you have your if-then statements and more of those conditions, you're gonna wanna do this.
okay, because I know like on the homework they threw in a ABC for the use the Euler diagram. It's like an ABC and then a conclusion.
Right, but then you gotta think about your text. It's saying all, some like that.
Right.
Those basically what you're gonna use Euler diagrams. When you get into all those connectors where your quantifiers and you have all that stuff with the if-then,
Okay. And can you define a tautology again?
all statements are true is true.
Okay.
Give you another one.
I guess you must want to take this one on the test.
Okay. I want you gotta know it. It's not hard. It's not hard. And he right, it's not hard. All you had to do is list, and I prompt you where you list your symbols first, knowing what your component statements are, getting what P and Q is. And all you had to do is read. And if it's actually gonna negate something you already have, you don't rewrite it. That's just going back to what we learned from the first couple of sections, which is 3.1 and 3.2. Then at that point, when it gets to therefore is the conclusion. So at that point, each sentence is a line, and if that's what I should have, each sentence is a line there. And then I have a line that implies my conclusion. This right here goes into a bracket. It's not hard. That goes into a bracket, but then this right here is a quantity. So you put it in parentheses, connect it with an and, put this in parentheses, connect it with an and then close the bracket off. That's what we have there. You which implies this last statement here. If the last statement is an if-then statement, you must put that in parentheses. Okay? And at that point, you're looking at your value there, which we already worked on, truth values, of coming up, how you coming up with those statements, and you had to break it up. You got your P and your Q and your R. So at that point, your P, your Q, and your R, you look at it. I also need not P, not P, not P, not Q, not R. Then I look at it, I know I need this quantity, I know I need this quantity, and then after I find each value of those, I'm going to put it all together. It's like order operation. Finding the true value of that. Then I find the true value of this whole thing, I'm going to put it together with this implies not P. And all I'm looking at it, if I get all T's in that last column, get off that phone. Then therefore I know it's valid. If I get one F or all F's or any F's in there, it's invalid. Are you following me? Any questions?